This video is intended to help you understand the notes for inequalities, solving two-step inequalities. Let's begin by accessing some prior knowledge. Let's recall, when is an inequality symbol preserved? So remember what it means to be preserved. That means it stays the same. So what operations can we perform and it will not affect our inequality symbol? Well, we know we can add, and we can add positives or negatives, doesn't matter. We can subtract positives or negatives. We can multiply positives, and we can divide positives. When we do any of those things, it does not affect our inequality symbol. The symbol is preserved. So that just says, well, when is the inequality symbol reversed? When is that not the case? It's a very specific time. When you multiply or divide by a negative. When we multiply or divide by a negative, greater than switches to less than, or less than switches to greater than, vice versa. So that is one of the most common mistakes that people forget to do. Let's consider, how do we use inverse operations when solving an inequality? Well, we did that last week already. We talked about what is the goal of solving. Let's start there. What is the goal of solving? That is to get one single copy, so one copy of the variable alone. And where do we want it? We want it alone on one side. If we're dealing with an equation, on one side of the equal sign. If we're dealing with an inequality, we want it alone on one side of the inequality symbol. And how do we do that? Well, back in the beginning of the year when we just had expressions, we learned how to do the math, how to do addition, subtraction, multiplication, and division. And so when we were simplifying, what we would do is we would follow GEMS. We would do groupings, exponents, multiply and divide, subtract and add. But now we're looking at solving. And solving is not when we do the math. Solving is when we undo the math. We undo the math. And to undo the math, we essentially have to unwrap the present, do everything in reverse order. So we would start with looking at subtraction and addition, then multiplication, and then exponents and grouping. Well, so far we did some of that already, but we had one-step equations, meaning you either added, subtracted, multiplied, or divide, all in one step. But we can do more than one thing when solving. We can do more than one thing, but when we do, we just have to remember that we are going to SMEG. We're going to go in opposite order of when we're just simplifying. We're going to start with what is on the side of the variable that can be subtracted or added to get rid of it, and then what is on the side of the variable that can be multiplied or divided to get rid of. Of course, then we would also deal with exponents, and then finally we would look at grouping symbols. So we need to remember that to get rid of subtraction, we use addition. Oops, that didn't, it looks like a funny. So to get rid of subtraction, we use addition. To get rid of addition, we use subtraction. To get rid of multiplication, we use division. And to get rid of division, we use multiplication. So let's give it a try. So remember, when we are solving, we want to get, let me write this down. We want to get the variable, one single copy of the variable alone on one side. And how do we do that? We're going to use inverse operations. So if it says to add, I'm going to subtract. And the same way, if it says to subtract, I'm going to add. If it says to multiply, I'm going to divide. If I'm supposed to divide, I'm going to multiply. And how do we know what to do first? Well, when we are solving, we do everything backwards. So we are going to do SMEG. We're going to do gems backwards. So I'm going to start with subtraction and addition, multiplication and division. There won't be any exponents today, but then finally grouping. Okay, so let's look at this. Let's do the first one. So let's try. We've got 2x plus 5 is greater than 13. So my goal is to get x all by itself. And right now, there's a 2 multiplied to it and a 5 added to it. So I am going to use the inverse operations to undo all those things and get x alone. And when I do that, I'm going to be going in reverse order. So I'm going to start with subtraction and addition, then multiplication, then exponents, then grouping. So first, let's look at the S, subtraction and addition. Well, right now I have something added to my x value, and that's a 5. I have plus 5. So the opposite or the inverse of plus 5 would be to minus 5. What I do to one side, I do to the other. That's how we keep balance. And I also know that adding and subtracting something does not do anything to my symbol. It preserves the symbol. So I'm going to carry down my symbol. Now on the left side, I can simplify plus 5 and minus 5. Those two add up to 0, so I don't see them anymore. I just have 2x. And on the right side, I have 13 minus 5, which I can simplify to get 8. So now the new inequality I'm looking at is just 2x is greater than 8. Well, I've done my subtraction and addition, so let's look at multiplication and division. Well, right now there's a positive 2 being multiplied to x. So the opposite of times 2 is divided by 2. And I know that dividing by a positive number preserves that inequality symbol, so I'll keep that there. But 2 divided by 2 is 1, which is good because I wanted to get one single copy of x alone on one side. And I did. And on the other side, I can simplify 8 divided by 2. 8 divided by 2 is just 4. So x is greater than 4. That's the solution to the inequality. All right, so let's try it again. I'm going to start back over. 5x minus 7 is greater than or equal to 8. So I'm going to first look at the S. Is there any subtraction or addition? Well, right now I've got 5 times x, and then I've got minus 7. So that is subtraction right there, minus 7. So the inverse of minus 7 is plus 7. What I do to one side, I have to do to the other. And I do know that adding something to both sides is not going to reverse my symbol. It's going to preserve my symbol. So on the left side, a positive 7 and a negative 7, they turn into 0. So basically they just disappear. I'm left with 5x. On the right side, I can simplify 8 plus 7. That's just 15. So I've done my subtraction and addition. Let's look for multiplication and division. Well, right now there is multiplication. There's 5 times x. So instead of times 5, I'm going to divide by 5. What I do to one side, I have to do to the other. I know that dividing by a positive preserves that sign. It does not flip it. So 5 divided by 5 is just 1, which is one single copy of x, exactly what I wanted. And on the right side, I can simplify 15 divided by 3, or 5 is just 3. So far pretty simple, right? We did 1 steps yesterday. Now today all we have to do is just see what do we have to do first. And we always look for what we can subtract or add first and then move on. So let's see how that might look different somehow. Well, let's look at this one. This one looks a little bit different because I see, let me go ahead and write SMEG up here so I remember what I'm doing. And let me see here. I've got this division bar, so it looks like a funky fraction. But I want you to remember, when we talk about grouping symbols could be parentheses, they could be absolute value, they could be brackets, they could be these fraction bars. So what we're going to do is we're considering that this fraction bar really just means that this thing is one value all by itself. So we're not even going to deal with that until we go to the grouping symbols at the end of SMEG. So first, subtraction and addition. Well, the only subtraction is inside that grouping symbol, but I'm not to the G in SMEG yet, so nope, nothing there. Multiplication and division. Well, I see right now that everything is divided by 3 on the left side. So the opposite of divide by 3 is multiply by 3. What I do to one side, I have to do to the other. So if something is multiplied by 3 and divided by 3, they turn into 1. So the only thing left on this left side is that stuff that's above the fraction bar now. So I've got x minus 4. That's the only thing left over here. And that is less than or equal to, well, I can simplify 5 times 3 is just 15. Okay, so now let's look again. We've done all this. There's no exponents. What was in the grouping was x minus 4, but it's out of the grouping now, so we can start back over. Is there subtraction or addition? There's subtraction, so let's go ahead. What we do to one side, we do to the other. Adding does not affect our symbol. It is preserved. You have x left on the left side, 19 on the right side. And you are solved because you have one single copy of x alone on one side. And finally, again, we're going to do SMEG. So first let's look for subtraction and addition. I see plus 4, so let's minus 4. What I do to one side, I do to the other. Got to keep it balanced. I know that subtracting does not reverse. It just preserves the inequality symbol. So I have x divided by 2 because these two things cancel each other out. And then 7 minus 4 is 3. Now I can look for multiplication and division. Well, right now I'm divided by 2, so I'll times both sides by 2. Those cancel, leaving me with one single copy of x alone on the left side, less than, well, 3 times 2 is just 6. So even though they can look kind of, they can look different, and you see things that kind of look like fractions and whatnot, it's no different than just using that reverse order of operations, but sticking with it throughout the amount of time that it takes to get x alone. So the goal of solving is get one copy of the variable alone on one side. So like just an x on one side. How do we do that? Well, we're going to use inverse operations. Inverse operations. So operations, what are operations? They're addition, subtraction, multiplication, division. So when we are doing math, let's say we started off this year simplifying, right? We didn't have any equal signs, simplify. All we were doing was doing math. 4 plus 7 times whatever. That's how we do math. And we learned that we can simplify using gems, meaning that the first thing that we want to do is look at grouping symbols. Then we want to look at exponents. Then we want to look at multiplication, division. And then we want to look finally at subtraction and addition. But that's not what we're doing now. Now what we're doing is we've got some equal signs or some inequality signs in there. So we're sometimes having to solve. So now we're solving. And when we solve, we've got this long complex statement and we're just trying to undo everything. We're trying to undo all the math and get x alone. Well, to undo things, we have to do all the stuff in reverse order. So first we're going to subtract and add, and then we're going to undo the multiplication and division. Then we would undo exponents, and then finally we would look inside grouping symbols. And just to remind you, the inverse of, let's see, let's do the inverse of addition. is subtraction. The inverse of subtraction is addition. The inverse of multiplication is division. And the inverse of division is multiplication. So those are your inverses. Those are the inverses. Inverse operations. Now, it is very important for us to remember that when you're dealing with inequalities, if you have a negative with the variable, and by with the variable, I mean a negative that is multiplied or divided. So when you multiply or divide by a negative, it will reverse the symbol. So that basically means it's going to flip. So if it was greater than, it becomes less than. If it was greater than or equal to, it becomes less than or equal to, and vice versa. Finally, there are 4 practice problems. Now, you do not have to submit them, so you don't have to submit them, but you must do them. You must do them. That's how you're going to know if you have any questions. So I want to remind you that you're trying to get the variable alone. Get the variable alone on one side. You're going to use inverse operations. And what order do you go in? First, you look for subtraction and addition, then multiplication and division. There will be no exponents, but they would come next. And then finally, if you have anything inside of a group, you can take it out at the end. So that means if it is in parentheses, or if it is maybe more complex like we had in our examples. All right, good luck. And once you're finished with that, we will have some other stuff for you to do.